In this video, we're going to graph a parabola with its vertex at the origin. It says graph the parabola given by the equation y squared equals negative 12x by selecting the correct symmetry. Then drag the point to the correct location of one of the endpoints of the lattice rectum. So they give us the graph. This is the actual graph. This is the correct solution here. But I want to show you how we can get to that. First of all, we can notice that we are in standard form, and y squared equals 4px is one version of standard form. The other version of standard form would be x squared equals 4px. Now, if you're in this version where you have y squared equals 4px, we're going to get either a parabola opening to the left or a parabola open to the right. And it depends on if our leading coefficient is negative or positive. In our case, we have a negative value here, so we're opening to the left. Now, if we have an equation that's x squared equals 4px, we would have a parabola opening up or down. And the same thing applies with positive being upward facing parabola, negative being downward facing parabola. Now, if I want to find the vertex, I need to see if this thing is shifted. So I'm going to actually put this in, this is standard form, I'm going to put this in a different form, so I'm going to divide by negative 12. So it's x is equal to negative 1/12 y squared, and I can see that there is no shift. Okay, I have no other constant out there, so there is no shift. So my vertex for this is going to be 0, 0. Right, I have no constant in there. Now, if I go back to this y squared equals 4px standard equation, we already have that written like that. So that means that 4p is equal to negative 12, which means p, if I divide by 4 on each side, is negative 3. So then I can use this value p to find the points for the lattice rectum. So if p is equal to negative 3, remember the lattice rectum is if we have the standard equation and we're opening to the left or to the right, our lattice rectum is going to be a vertical line where its x is equal to negative 3. So then I would take that piece, plug that into our original equation, which was y squared equals negative 12x, and I'd get y squared is equal to negative 12 times negative 3. So I have y squared is equal to 36. Square root each side, I get y is equal to plus and minus 6. So my lattice rectums, or my lattice rectum endpoints, I should say, would be negative 3 and positive 6 and negative 3 and negative 6. And you can see that we have those 3 points, right? Vertex, one of the lattice rectums, and the other lattice rectum would be negative 3 and then positive 6. And so that's how we would graph that parabola.